I hope everybody is rejuvenated, refreshed. So let's get on with the next session. It is called Multiple Plot Lines, Regional Strategies. So what we are going to try to cover in this session is that there are a number of starting points for different regions when they are trying to find ways of decarbonizing the steel industry in those regions. There are, of course, constraints both in terms of the raw materials, scrap, as well as energy. So not everybody is blessed with the same opportunities. We need to be mindful of that. So we are going to try to highlight all of those possibilities. So there is no one single path to Rome. All roads are going to lead towards Rome. We have got that another, let's call it a sister event, which is the Breakthrough Technology Conference. I'm going to bring some of those learnings from there, talking about what sort of technologies we are working on and at what stage we are. How do we expect them to mature? What sort of things would be needed for them to work? And that is the very crucial point there. It's not just about developing technology, it is about making it work, and then there are some conditions that are required to make those things work. Following that presentation, or a little overview, I will hand over to Mr. John LICHTENSTEIN from Steel Dynamics. So he's going to present an overview of the challenge in big numbers. And that will be followed by a panel discussion with the panelists that we have on the stage there. I try to make sure that we get as many regional voices as possible, because it's important for us to have that bigger picture there. The world is not a uniform, homogeneous place, so we need to be as inclusive as possible to get that perspective there. So let me now start with my presentation. And before I forget that, the presentations are kept to a minimum. So 10 minutes I will take. I will give 10 minutes to John. And then the rest of the time we are going to spend in getting that holistic overview from the globe. So I have titled Pathways to Low Carbon Iron and Steel Making. So I'm going to give you some of the learnings that we got from the event. We have had 2 events by now. The first Breakthrough Technology Conference took place in Abu Dhabi in 2023. And the second one was last year, December, in Singapore. We continued the discussions on the actual technologies that we are working on, but we included those conditions that I highlighted earlier there, that there are those things that are going to make those technologies work. For example, the provision of huge amounts of green energy. Do we have access to that? How do we see that developing forward? So we brought that kind of debate into the mix as well. Also, we keep hearing about scrap, the type of raw materials that are needed to make that change there. So we expanded the discussions, not just only technology, but the other necessary boundary and necessary conditions into the mix. So that's the picture that you saw this morning. It was yellow. Miraculously, now it is green. So here, we see the portfolio developing into the future. As Osa explained there, we try to look at it from a slightly different angle there, how much effort it requires in terms of developing site infrastructure, as well as the time for maturity. So there are some low-hanging fruits in the corner of the X and Y axes. Electrification and scrap is quite easy. So if you have got access to clean and plentiful of scrap and electricity, you can make that change quite easily. And the time required is also very short. But the more you go towards the radical transformation, the hydrogen, carbon capture and storage, the bubble starts increasing. So that means that the investment and effort required goes higher and higher. And also the window shift from 5 years to 10 years, 15 years, and so on and so forth, because that transformation is quite radical there. So we see quite a number of those projects that are outlined there. This is not all what the steel industry is doing, but these are the projects that were presented at the conference. So we saw these projects and have tracked them since 2023, so there is a lot of change happening there. So we see that from 2023 to 2025, that we see that they are scaling up. And from 2030 onwards, it will not be the technology itself which is the constraint. We see and expect that those technologies are going to mature. That's when the energy is going to increasingly become important there. So if hydrogen-based reduction becomes mature there, then we do need that answer. Where is that energy going to come from? The tremendous amounts of energy, because you cannot bend or break the laws of physics. The same energy would have to come from somewhere else. So in terms of quantified emissions, you will be familiar with this type of chart from somewhere else. If you can decarbonize by process improvements, the existing setup, that is the blast furnace, you can reduce 5 to 15% CO2 quite easily. We have tested that program using step-up methodology that was developed by WorldSteel, and we have done over 25 site reviews. So that methodology does work. If you start switching fuel by using, for example, biochar, natural gas, or if you have got access to hydrogen, you can start shaving off quite a number of those CO2 emissions. And when you reach the bottom end of that table there, that's when we see the hydrogen, which is going to, or which has got the promise to reduce 80 to 95% of the CO2 emissions. But the lower you go down this table, it requires structural transformation. So it requires a lot of effort there. In terms of capital, people talked about that. Okay, where is the money? Who is going to buy that steel there? So it all depends. These topics or issues, they are interlinked. So blast furnace modification is relatively easier. You can do that, retrofitting some of the technologies. Switching the fuel in the blast furnace, also quite easy. So the first 3, 4 are retrofit. So that gives me quite a lot of hope that even the blast furnace has got a huge potential of CO2 reduction to the tune of 30 to 40% CO2 reduction. And that's a number that can be demonstrated, and we see quite a number of those projects being talked about in India, in Japan, in China. So we have launched a program which is going to look towards those sort of possibilities where we have got something that can be shown. And 40% is a number that we can be proud of. Yes, 100% we will get there, but there is some time to go there. So in essence, you can easily extend or extract the possibilities from the existing infrastructure, and then using the transition path, bolt-on technologies, and then the structural transformation which requires us working on energy provision that can lead towards hydrogen decarbonization pathway. So again, this is just a rehashing of what I have already said there, that we see that there were pilots which are now being scaled up, and 2030 onwards, we see transformation governed by energy dynamics. And that is something that is going to be probably discussed later today or tomorrow. Another thing that we tried this time was a workshop on the different decarbonization pathways. We are going to do something similar here, but not just only about technologies, but how those pathways are constrained by the worldview of different regional dynamics, constraints, and everything else. So some of the participants from there are represented on this panel today. So with that, I will just stop here. So there are some barriers there: energy, hydrogen, scrap. Again, there is not enough to go around. We have only so much that can be kept in circulation there. Our needs require us to make steel from virgin ore as well. So 2030 onwards, we can expect that there will be quite a number of those transformational changes there. And I'm hopeful, looking at some of those technology development programs, upscaling, that the moment they start getting on a commercial scale, that is going to boost the investor confidence, because that's a very, very important thing. That the moment we have got a working, showing example, is going to boost the confidence in what we do. So now I will hand over to John Lichtenstein.
Okay, good afternoon. I'm going to offer some thoughts and perspective on one of the questions that was sort of raised in the morning, which was, where are we today? Where is the global steel industry in its decarbonization journey? And perhaps more importantly, what's the trajectory? Where are we headed? Not in terms of what we would like to have happen, what might happen, but what we think is the likely, frankly, pace of decarbonization. What are the sources of that? And you'll see that we have a series of forecasts to 2040. We think of, and again, this is what I'm going to present today, is just some global numbers, but it's not top down. Our numbers are sort of built country by country, almost plant by plant, in terms of energy mix, raw material mix, CO2 intensity of electricity grid, on and on and on. So what we have and we'll present is kind of the global roll-up, if you will, of all of those. So let me proceed. Okay, looking on the chart, and do we have laser pointer or no? We don't. Okay, not so good. Okay, all right, so on the left is the sort of stack bar of total global CO2 emissions, right? So I'm dealing with CO2, not greenhouse gas. And by our modeling, 2024, there's about 3.66 billion tons of CO2. Of which you'll see China, and this particular segmentation is China, advanced economies, and the rest of the world. And we see that 3.66 declining 24% to 2.770 by 2040. And you'll sort of see a little more the country and region specific source of that, but you could sort of see right off the bat that China is contributing almost, in our modeling, 1 billion tons of CO2 reduction. And you'll see the emerging economies, total CO2 emissions are declining, whereas the rest of the world is increasing in total quantity and in the percentage contribution. What does that mean in terms of intensity? If you look all the way on the right chart to the right, our global average, we see the global average industry intensity moving excuse me, from 1.94 to 1.73 by 2030, down to 1.45. So stepping back, again, we see that the global industry will be able to reduce its CO2 emissions by roughly 24% by 2040. Good news, bad news. I'm sure there's a whole range of opinions about that. And again, as I think about it, that's a stake in the ground. And what I'll come back to is what happens after 2040. But our view is that the emissions trajectory, the global emissions trajectory to 2040, I don't want to say it's locked in, but I think there's limited degrees of freedom the industry will have in terms of even accelerating decarbonization to a greater extent in 2040 than shown here. A lot of those reasons have to do with just technology maturity. I think we have a somewhat more conservative view than Rizwan as to how quickly some of these technologies will be commercialized, impacted, of course, by scrap, availability, on and on. So we'll come back to that, but again, here's where we plant the stake in the ground for 2040. Now, how do we get there? What's actually driving that? Okay, we model basically 5 or 6 different drivers of decarbonization. So what's contributing or what's driving that reduction from 2.66 down to 2.770? First thing, and moving from green bars left to right, production change, very small impact. We actually see, whole other discussion, but global steel production being sort of range-bound to 2040 in about the 1.9 billion ton range. We see shifts in the mix of that production country by country, contributing a small amount, 65 million tons of reduction. Moving to the right, the big bar, 430 million tons. We think the conversion I'll put it this way, the growth of EAF production globally is going to contribute about 430 million tons of reduction, including the impact of DRI. And of course, DRI, if you're using natural gas DRI, you're actually adding to global emissions. So that 430 is sort of a net combination of the EAF conversion, but also the CO2 that originates in the natural gas process. DRI, H2, 14 million. We're pretty, say, pessimistic, but we do not see hydrogen production, DRI, as having a major effect in this time period to 2040. I think we're seeing, if I'm remembering my numbers right, that they're saying that we estimate there'll be about 15% of the total reductant requirement for shaft furnaces around the world being hydrogen-based in 2040. So 15% global average, some are more, some are less. That 15% yields your $14 million savings, if you will. Grid intensity, obviously, as all the countries and companies within countries are accelerating the transition to renewable energy, that makes a contribution to the reduction. Blast furnace hot metal ratios, BOF hot metal ratios and blast furnace actions. If you take those two together, you get to almost the same equivalent contribution reduction as the EAF conversion. BOF hot metal ratios, again, the ratio of iron to scrap in your BOF. We see the global average moving from about 84% to 82%. When people think about scrap and the decarbonization value of scrap, they really, your mind goes directly to EAFs. Fair enough. But the marginal contribution or the marginal benefit of a ton of scrap going into reducing the iron in a blast furnace versus going into an extra EAF capacity varies region by region, right? So we actually put a fair amount of assumption as to the proportion of scrap, rising scrap availability, that will be used to reduce the blast furnace BOF route. Blast furnace energy, we've talked about this. It's, we see in this time period, again, for those of you who keep track, fuel intensity going from 518 to 495 kilograms per ton of hot metal, similar reductions in coke, et cetera, et cetera. Carbon capture, again, we see very little, call us pessimistic, but we have a much more conservative view. We do not see carbon capture as a blast furnace is having a measurable impact at all by 2040. We do see it, and that figure there represents carbon capture for DRI. Okay, so I have to go a little more quickly here. So what's behind some of these numbers? EAF production. On the first chart on the left, we have our estimate of the global share of EAF production going from 29% to 48% over this period of time, not quite touching 50% by 2040. If you look on the right, you see what that intensity is, what those production shares are by year, by group. And so again, all the way on the right, global going from 29 to 48. If we look at China, which all eyes on China for this, we see China's EAF share going from 10% to 15 to 32% by 2040. Again, be very interested in Mr. Huang's sort of response to that. Real quickly on steelmaking metallics. Excuse me, now let me go right to this. This is another way of looking at the what's behind that shift in global emissions from the 3.66 down to 2.77. To the left, you're basically the, in green, are all the regions that have a net reduction in total CO2 emissions during this time period. And then as you move from the center to the right, those are the regions where we're seeing, where we anticipate an increase in total CO2. And just to kind of clarify that, the CO2, where we're seeing CO2 increases, certainly starting from other Europe, Turkey, Latin America, where part of the increase in CO2 emissions comes from just increased steel production, right? So you're actually, you know, if you unwrap those numbers, you're going to see actual decreases in intensity, but in absolute tons, and again, industry kind of focuses on intensity as we should. What the world cares about is tons, right? So we always got to keep that in mind. But again, you see the outsized contribution of China, almost 1 billion ton reduction. Again, a combination, not just the CO2 EAF conversion, but you know, our view of what steel production in China is going to be by 2040. We put it at around 800 million versus the billion. That will have a huge impact, a huge driver of reduced CO2 emissions from China. Okay, good. Try and wrap this up. So what this chart shows is the progression of the where we are today, and this is the intensity and total emissions. We're at 1.94 tons per ton, excuse me, kilograms per ton, sliding down, or the progression to 2030 of 1.73 and 3.26 billion tons, down to that 2040, I'll call it stopping point, but marker in the sand of 1.45, 2.770. Okay. Again, we can. That's a stake in the ground. Good, you know, good discussion at the right place when there's time. You know, is that the right number for 2040? But again, our view is that's not locked in, but we see not a great deal amount of flexibility in that, having to do with again technology development, capital lead time, scrap availability. And if we just continue that trajectory, we bring the global emissions down to by 2050, bring it down to 1.1 kilograms per ton, or 2.265. That's a 38% reduction versus today. And that, again, that's basically just keeping the same progression. It's keeping the same rate of improvement that we see from 2024 to 2040 continuing. However, we think, and I'm sure many folks here would think, that there's going to be acceleration. And again, our view of the technology maturity is that we're only going to begin to see a large impact in the emerging or disruptive technologies after 2040 in terms of moving the needle. So another trajectory would get it down to 0.92 or 1.830. We think that is a very realistic target for the industry. Target's a tough word, but estimation of where we might be at. And then beyond that, you know, can we get to 0.5 or 1.1 billion? And, you know, the devil's in the details, and we'd have to kind of unpack that. But basically, that's kind of where we see the industry today, what we see the trajectory is based on the accumulation of all these impacts, and would like to be proven wrong as far as how quickly we could move. So with that, I will end my presentation, and we'll go to the question Q&A. Can we shut this off? Thank you. Thank you. You know, I might stand here just because it's easier for me to see everybody this way. Okay, so what we're going to start off with is I'm asking the same question of all the panelists, kind of on behalf of, you know, to speak on behalf of, or maybe not on behalf of, but in terms of what's going on in their regions. And it's a two-part question. Number one, what's driving industry decarbonization in your region, right? Is it carbon pricing? Is it mandates? Is it customers? Is it financial institutions? What's driving the decarbonization we're seeing? And then the second part of that, what's the constraint? What are the constraints on moving faster? And again, in that sort of answering, what the technology is and, everything that Rizwan has sort of pointed out kind of comes into play on that. But what's driving it and what are the obstacles moving forward? Starting with Kevin.
Okay, thank you. Is this on? You guys can hear me
You're
okay?
on, yeah.
Great. Well, thanks, John, and great to be with you all today. For the United States, I think the story is a pretty simple one. We've talked about this at previous conferences. Driving decarbonization in the United States, first and foremost, is the shift to EAF. We're probably approaching 75% EAF production in the U.S., 25% integrated. And so there's an inherent advantage with EAFs in terms of lower process emissions. Obviously, depending on the product you're making, you're going to need, especially for flat-rolled products, some ore-based metallics. So then the nature of the ore-based metallic and the increasing investment in direct reduced iron to be coupled with EAF production, I think, is another factor that is helping to reduce carbon emissions in the U.S. industry. But all of those factors are largely being driven by the market. This is not the result of any government mandate. It's not the result of any type of carbon pricing. It's a combination of what the customers are asking for. I mean, I think there is demand for steel with lower carbon emissions, but equally important is just what's the most cost-effective way to make steel and with lowest energy consumption. And so that's driving, I think, the shift towards electrification, EAF production, and then on the DRI side, the abundance of natural gas is promoting greater investment in DRI production. So those are, I think, probably the major factors driving what's happening in the U.S. In terms of obstacles, obviously, using natural gas for direct reduction gets you a significant reduction compared to a traditional blast furnace, but it doesn't get you to zero. So the biggest obstacle, I think, to really getting to near zero for the entire steelmaking fleet in the United States is the limited access to alternative reducing agents, whether that's hydrogen or whether it's something else. Obviously, there were a number of efforts being made by a previous administration to try to promote the increased use of hydrogen. All of those seem to have failed and are not being pursued right now. I will say that I think that what's maybe more promising in the near term in overcoming that obstacle are some of the startup operations by companies in the U.S. looking at alternative iron-making technologies, whether that's electrochemical or molten oxide electrolysis, but those are still at the early stages, but I think there's a lot of private investment going into those options, and those could be another way of overcoming the iron-making obstacle.
Great. Thanks, Kevin. Dr. DOHNOMAE, please.
Okay.
Please.
My name is Hitoshi DOHNOMAE from Nippon Steel Corporation and from the Japan Iron Steel Federation. So I'm a representative of the Japanese situation. So first, this question is what is the key drivers, okay? Yeah, and first, I want to emphasize that decarbonization is no longer about reducing emission, but we have entered an era. What can it be monetized in the market, or is it a value within the supply chain, or is it recognized under international rules, or can it be explained to the capital markets? So this trend is becoming global standard, I guess, but Japan is especially aiming to creating value in the market as a prioritized policy. So a prime example of this is Japan's green steel, or GX steel. GX is abbreviation of green transition, but we are focused on GX steel. Japanese government is focused on the, not focused on green, but focused on GX. GX means that we are focused on the decarbonization and economical expansion. Both we are pursuing. So, in that sense, decarbonization industry of steel industry requires innovative technology, massive investment, and long-term payback periods, making it a sector that cannot be sustained by traditional market mechanism alone. So, GX steel is not merely a commodity, but is designed as a mechanism that shares its reduction value within the supply chain and contributes to the customer's Scope 3 reductions, which means that we are applying a kind of chain of custody methodology for generating GX steel. And the Japanese government has introduced policy measures creating initial demand through public procurement and subsidy program for our customers, such as automotive sector. In other words, Japan is focusing not on how to implement decarbonization, but on how to make decarbonization economically viable. I believe this is a key driver unique to Japan, symbolized by GX steel. That's all.
Okay, thank you. Dr. GHENDA, please.
Yes, thank you. Thank you very much. I will give the perspective from the European steel industry. When it comes to the driver for decarbonization, I would say it's a combination of many factors. It's not only carbon pricing, it's not only governmental legislation, but it's really a combination. So we will have, on one part, we have climate policy, we have the demand, the requirement for the customers. It's also a matter of competitiveness and everything put together. So what do we see the bottleneck? So I would say that we need to deliver climate neutrality that is in the law in Europe, but still decarbonize, strengthening the competitiveness of the steel industry, and also avoid dependency when it comes to strategic material. We need to see also that we have a resilient industry. For decarbonization to happen under these conditions, then we need to make sure that the companies can have a genuine business case to drive investment in decarbonization technologies. Now, to have this business case, we need to fulfill certain conditions. First one is on trade. We need to address global overcapacities. We need to make sure that we can address unfair trade issues, competition, and all those things. We need to make sure, second, that we can avoid the relocation of industry from Europe to some other region who doesn't have or have climate legislation that are not as ambitious as in Europe. We are talking about carbon leakage. Yeah. So making sure that steel produced in Europe and imported will be facing the same carbon cost. So, and then the technology we're looking into when it comes to decarbonization will need a lot of energy. So we need to have available cost-competitive energy and raw material. The new technology will cost a lot of money. We need to make sure that we will find support for the investment. We're talking about CapEx, but also support to cover the OpEx, because OpEx will be much higher. Then the product that the new low-carbon product will cost more than those those that are actually produced via conventional routes, so that we need to have lead market to support the demand for this product. Now, all these challenges need not to be taken into isolation. We need a set of measures that are really well thought in order to make sure that we can have this business case we're looking into. So,
Thank you. Dr. Huang, please.
Thank you. I'm Huang Dao from China Iron Steel Association. I'm glad to take part in the climate action open forum 3 times since 2023. I'm sharing that my English is not improvement. Although the technology in CO2 emission is improved a lot, the technology is formal, but my English is reducing emission. So if I have some language challenge, I will ask my good friend Alan to help me. The chairman asked me some questions. I wish you remember 3 keywords in my answering these questions. Firstly is action. The another is innovation. And the third is cooperation. As you know, in my opinion, the key drivers for decarbonization of China's iron steel industry, if it is ranked by influence, they are policy-mandated downstream customer requirements and carbon pricing mechanism. All these are underpinned by effective implementation and execution, which are core strengths of China. What is the Chinese government asked to do? The iron steel companies in China and the iron steel sections must to do. So I think this is the first one. China's steel industry pushed green and low carbon development for long-term growth. Over the past 5 years, 3 major projects I said in the last forum. They are the ultra low emission for the pollution emission. Energy efficiently optimizational and digital transformation have been fully improvement. For the new 5 years plan, since this year, 3 new initiatives are now under in the way, which included about better product quality. The second is higher energy and carbon efficient. It's linked about the climate change CO2 emission. And the third is the smart digital transformation. So I think the action is very important to get the achievement and on the technology and what is the prices technology are be adopted. I think low profit margins of China's steel enterprises this year. Investment risks in low carbon technology innovation. The lack of cost-sharing mechanism for decarbonization and the high costs of raw materials, and fourth, requires for low carbon production are major barriers to decarbonizations. On the other hand, decarbonization technologies are not have yet to reach mature application stages. So China's iron steel industry have deeply recorded through years of practice what we must join hands with upstream and downstream partners in the green discussal chains. I ask my good friends to speak a little what is not clearly to my friends. Thank you.
Microphone.
Can you just,
There we go.
switch on?
There we go.
Okay. So in Huang Dao's answers, that he emphasized that the key drivers of the decarbonization of China's industries, if it's ranked by influences, it covers 3 aspects, which are policy mandates, downstream customer requirements, and carbon pricing mechanism. And then in the last 5 years plans, the major programs we have done is on the outer road emission, energy efficiency optimization, and digital transformation. And in the next 5-year plan, there will be 3 new initiatives, and which is underway, which include better product quality, higher energy and carbon efficiency, and a smarter digital transformation. This is my summary. Thank you.
Yeah. Thank you. José.
Thank you, John. Thanks for having me. From my perspective as a Latin American representative, I think I'm the small elephant in the room, representing only 3% of the emissions or the steel produced worldwide. So having said that, to answer your question, John, I think that in Latin American countries, we have as much combinations of situations regarding the market, regarding technology, regarding the availability of raw materials or reductant agents. No common ground, it's no willingness to pay. Unfortunately, public policy are not a driver to decarbonizing so far and so good, because we believe in private decision making in order to make it competitive. Of course, you need common grounds to make investments, but not having any carbon tax or ETS in place. I think they work the other way around. Instead of incentivizing decarbonization, I think it scares out investments. At least this is what we are seeing mainly in Mexico, in Brazil, and Argentina. But the exception to the rule, just to jump into the technology, is the investment that Ternium, in particular case, it's about to commission by the end of this year. It's a new steel-making capacity, slab mill, based on natural gas DRI, with a capacity of carbon capture and usage, the CO2 that we already produce in the sites we operate already in Monterrey and Puebla, and the flexibility of switching from natural gas to low carbon, hydrogen, whatever that comes feasible. Technologically speaking, it's out there. The problem in Monterrey, in Pesquería in particular, is that we don't have any water. So we are working on turquoise hydrogen thesis. This is taking natural gas, which is available and abundant and affordable, and cracking the molecule to get a carbon solid and hydrogen as low as carbon footprint the energy matrix is. So I think this is a flagship of decarbonization that Ternium, as a big player of Alacero, the Latin American Steel Association, is a really good example of how one of the players it's driving the decarbonization, depending on the market, depending on technology mastering, like I mentioned. And yes, we struggle sometimes with policymakers when they try to make decarbonization an argument to get more revenue through national or state taxes.
Okay, thank you. Thank you, everyone. I'm going to ask a question that wasn't previewed with you, but I think each of you has sort of mentioned it one way or the other, which is question of green steel premiums, right? So we go back 3 or 4 years ago, you know, there was a lot of excitement in the industry about hydrogen, about carbon capture, and about green steel premiums. Sure, those were kind of the 3 pillars of industry, you know, the way a lot of people thought about industry decarbonization a couple of years ago. Where do we sit in each of your regions or each of your countries as far as green steel premium? And what's of course interesting is it's the automotive sector which has sort of taken the lead on this for understandable reasons. Each one of you, you know, are suppliers in your countries and regions. Automotive is a big important market in each one of these. So curious as to, you know, how you all are seeing the prospects of green steel premiums as a way to, of course, help finance the transition. And again, because this is a question out of the blue, why don't you all sort of individually answer that, then, you know, rather than going down the line. So as you formulate your answer, you know, just go for it.
I can
Please,
jump
Jose.
in, since I have the mic.
Yes, please.
As I said, these pesquería sites will deliver specific steel grades to automotive industry, which is in fact the most sophisticated market that we face. I deal personally with the expectations of most of the automotive companies, and they definitely do not give us any signal of any willingness to pay a premium, unfortunately. And in fact, the other thing that I wanted to share is that they do not have already, most of the customers of ourselves, at least, do not have any genuine expectation on having a low carbon footprint to make any claims over the final use or construction phase of the car. In fact, most of the automotive makers do not have any target. So I wonder if this is a proper signal to us to drive to that task.
May I ask
Please.
your question? What kind of green steel you are proposed?
No green steel, just genuine low carbon steel through this natural gas GRI with carbon capture and usage, and of course scope 2 very low. In fact, one of the challenges that Mexican grid has is to reduce national grid. It's not happening that in Argentina, which is already clean, and we have invested in lowering up to 90% the scope 2 emissions.
Yeah.
Dr. DOHNOMAE, I mean, since you have the microphone now, are the car companies in Japan willing to pay a premium? And also, of course, the Japanese car companies are everywhere. So will they pay a premium in Japan? Will they pay a premium in the US? Will they pay a premium in Europe?
Basically, no. Basically, no.
That was easy.
Almost all our customers don't want to pay premium. Yeah, that's a fact. But as I mentioned, that we propose a kind of green steel. We call it GX steel, which we apply a chain of custody methodology to reduce drastically carbon footprint of our products. But in that case, some customers always ask us, that methodology can be appropriate, or where some kinds of standard allowed to use chain of custody methodology, or some kinds of complaint. But some customer willingly pay. One of the automotive company willingly pay for the premium. And also, as I mentioned, that Japanese government are very supportive to the methodology, and they introduced kind of public procurement program to for the company public procurement program to for the government to buy the products which use GX steel, and also subsidize automotive company, which company buy GX steel. That kind of measures make some kinds of initial small demand for GX steel.
So it's, if I'm understanding you correctly, the customers are not paying a premium, but the government is effectively paying that premium because they're subsidizing the. Okay.
But a small amount of small amount of customer will pay for the GX steel.
Someone, please, Kevin.
Yeah, I'll say in the U.S., I think I agree with what Jose has said before. I think the customers generally expect the steel that meets their specifications. They want the highest quality at the lowest price. And of course, what any individual steel company, what their arrangements, their contractual arrangements with their individual customers are going to be, that's going to be between them. But at this point, I don't see, first of all, there's not a big demand for the auto companies to document a certain emissions reduction on their Scope 3 emissions. So if they make future commitments on that, maybe that would change the situation. But for now, I don't see the, at least from public data, any evidence of a green steel premium.
Dr. GHENDA, please.
Yes, in Europe, I will support what you have said. So, customer would like to have steel with low Scope 3 emission for them. So, but who want to pay more if we can get it at lower prices. What is important is to make sure that we have demand for this low carbon product. If we can already start with public procurements, that can help. That is a discussion that we are having actually in Europe. Now, when we come to public procurement and low carbon steel, we need first to define them. We need to have a methodology, how we want to define them, and then later on, we need to make sure that we can certify to avoid greenwashing. If we can start with public procurement, that would be terrific.
Good, thank you. And clearly, some of the panels that are coming up over the rest of these days are going to address that question of standardization, interoperability, et cetera. So that's clearly a piece of this. Dr. Huang, do you care to comment on the green steel premium? No. No. Okay, fair enough. Okay.
That's a yes.
Okay, thank you. Dr. GHENDA, again, thinking of the EU, the EU was kind of, a number of years ago, the poster child, right? It was the sort of, pick your metaphor, the tip of the spear, right, as far as decarbonization of the industry. A lot of EC support, in terms of direct, call the word subsidies, direct payment for DRI plants in particular. Because of the energy issues that you've mentioned, the number of plants that are being built in the number of DR plants being built in Europe that are currently sort of underway is a much smaller number than what was anticipated, right? So my question is, given the realities of not enough hydrogen, not enough low-cost hydrogen, given the reality of persistently high natural gas prices, how do you see the kind of the overall strategy or profile of the European industry pivoting? And one other piece of that is, and we talked about, even with all of the expected production of DRI in Europe, there was also an expectation that a certain amount of green iron would be imported, right? And that was sort of at least a lot of discussion. Given what's going on in the Middle East now, is that still an option for the European producers? So, please.
I think we have been working on our roadmap, steel roadmap, how we want to decarbonize steel production in Europe, but looking at the evolution, global evolution, geopolitical evolution, we need to recalibrate. That is what is happening actually. When it comes down to DRI EAF or DRI smelter, and then you continue with BOF, and downstream. So what we see there is that we have a lot of projects. Now some are ongoing, some has been postponed because we don't have these hydrogen. We need low carbon electricity and the costs are very high. So what could be the scenario in the future is that some DRI will still be produced in Europe, but we need to make sure that we will be having enough. If we don't have enough, then we will be importing HBI.
Yeah.
So from our projection, we think that by between 2030 and 2040, let's say, 1/3 of the steel production over the actually BF-BOF route could be replaced by DRI, EAF. That is, those are the projections when we look at what is happening actually. Now, if you have that in mind and look at the projects that are ongoing now, then you can have an idea on how much can be imported. Let's say we will need about 2 million tons per year. If you take half of it, it will be maybe 15 million tons that you need to import. The question will be, if we have to import 15 million tons of HBI, I don't say that will be the number, but let's have an idea. Do we have the logistic? That is the first question. The second question will be, how do we address safety issues? So those are the questions we need to discuss. And then, so how does it look like when it comes to long-term procurement?
Yeah.
So contract, all those things, in order maybe to avoid the monopolistic situations where you have only some who can have access to this raw material that we are all looking for.
Thank you. Dr. Huang, if I may ask you a question. When people think about China decarbonization, they first think about EAF. But as we've seen, and I think as the World Steel sort of technology awards, China's steel companies are also kind of leading innovators on blast furnace technologies. So my question is, again, how do you see the balance over the next 10 or 15 years, as far as particularly the EAF share is the first metric, but in general, between EAF and blast furnace steel over the next 10 or 15 years?
Thank you for your questions. In my opinion, China is not have much oil and natural gas. China's existing and under construction green hydrogen annual capacity exceeded 1 million tons, accounting for all half of the global competed capacity. By 2025, our capacity reached the green hydrogen is about 250,000 tons per year, represent about 50 to 65% of the global total. If we improvement DII and EAF this progress productions the green hydrogen is good for this road. But as you know, the China linked about the scraps, not enough scraps. So on the other hand, when it comes to green hydrogen demanded, China's environmental government have rolled out stranded rollers for clean up the transfer about the logistics. Demand for hydrogen will be growth remarked in the applications such as hydrogen power heavy trucks, locomotive and copper ships. Under scrap oil prices level, these hydrogen floated, we reached offer strong cost effectiveness. On I said that the innovation that the technologies, although China's industry needs to advance its low carbon transition through dual-track approach. When it comes to the conventional long-term roads in integrated steel making, BF, the hydrogen-rich carbon recycling blast furnace technology has been built in full cycling demonstration project by Baowu Steel companies, Sino Steel, MECC. As for the short process EAF steel making, we are for-pot hydrogen enriched and pure hydrogen gas-based DII technologies into industrial use. This covers hydrogen-based shaft furnace and furnace bed iron making. In your presentation, you mentioned the iron steel group, smelting, reducing, fluidized bed technologies. And the 4 production lines are now running at Hebei Iron Steel Group in Zhangxuan Technology, and in the Baowu Zhanjiang Group. Before 2040, decarbonization technologies for China long process steel making will serve as main contributor to carbon emission reduction. I think after 2040, short process technology will play increased significant roles. If I not clearly ask Ilan, yeah, explain.
So let me clarify that China's existing and under construction green hydrogen annual capacity exists 1 million tons, which accounts for over half of the global committed capacity. By 2025, our capacity reaches to 250,000 tons per year, representing about 50 to 65 of the global total. And when it comes to the green hydrogen demand, China's environmental authority has rolled out very stringent rules for cleaning up bulk industrial logistics. Demand for hydrogen will grow remarkably in applications such as hydrogen-powered heavy trucks, locomotive, and cargo ships. Under the current oil price level, these hydrogen-fueled vehicles offer strong cost effectiveness. Even so, high green hydrogen's costs remain a key constraint for steel industry in achieving decarbonization through hydrogen metallurgy. And indeed, China's steel industry needs to achieve its low carbon transition through a dual-track approach. But when it comes to the traditional integrating steel making, the hydrogen-enriched carbon recycling blast furnace technology has been built into full-scale demonstration projects by Baowu, China Steel, and MECC. And as for EF steel making, we fully put hydrogen-enriched and pure hydrogen gas-based DRI technologies into industry use. This covers hydrogen-based shaft furnaces and fluidized bed iron making, And the full production line are now running at HBI's junction technology, Baowu Zhanjiang plant, and Ansteel Group. Thank you.
Thank you. Sticking with hydrogen, Dr. DOHNOMAE, I guess two parts. You know, one is the status of the supercourse
Course 50.
program. I mean, that, you know, my understanding is when it was sort of rolled out a couple of years ago, it made an assumption about 50% by 2050, 2060 would still be blast furnaces, but with hydrogen and carbon capture. My question now is kind of what is the status and what is the thinking, particularly for Nippon Steel, which now through the U.S. Steel acquisition and Big River Steel as being one of the foremost EAF producers, and then of course building your own EAF, is the thinking of Nippon Steel, is the thinking of the Japanese industry as a whole shifting a little bit away from Supercourse 50 or something else, please?
Thank you very much for your question. Yeah, you made two questions, but easy to answer is the second question. Yeah, EAF, shifting EAF is a main cause of us. Is no, completely no.
Okay.
Yeah, EAF is one of the important technology, but we think that the primary steel making, decarbonization of primary steel making is the most important mission of us, because we cannot rely on 100% scrap, and also it's a supply and demand gap, and also the quality, scrap quality is enough. So we want to supply high value added products of our customer. In that sense, scrap is not enough. In that sense. So we still continue to investigate hydrogen blast furnace system because, of course, we also investigating hydrogen DRI, but the more realistic measure is introducing hydrogen into blast furnace, because we have already established the steel product making system with blast furnace. So we have investigated with a small size blast furnace, and we confirm almost 45% reduction with the test furnace, and we are going to launch the experiment with the commercial size, 5,000 cubic meter blast furnace in Japan. By using that, we introduce high temperature hydrogen into the blast furnace, and we want to confirm. But unfortunately, the hydrogen is gray hydrogen, because we cannot get green hydrogen, but we can confirm the maturity of the technology from this year.
You actually answered the next question I was going to ask. I mean, when you announced the 30 to 40% reduction in, through hydrogen in your small blast furnace, that got a lot of attention, right? And you say you're building a commercial scale. What's the timeline? When do you expect to have a commercial scale furnace running with?
Maybe the commercial size experiment will be finished in 2 or 3 years, I guess. And we will wait. The hydrogen will come, green hydrogen will come. So in that sense, hydrogen-ready blast furnace technology will be established in the near future.
Okay, good. Kevin, you. It's pretty clear that the current administration in Washington is not in favor of renewable energy and has taken a lot of steps to either shut down projects that were started, to encourage more use of coal, and in general, sort of try and move the country away from renewables toward fossil fuel. How is that change in, I'll call it policy or the government position, how is that impacting the steel industry's decarbonization?
Yeah, thanks, John. I honestly don't think it's having a major impact on the steel industry in the U.S. First, you have to remember, if you look at any of the data, while, yes, the Trump administration is trying to move away from renewables, and they have stopped a lot of offshore wind projects, overall, still, the fastest growing part of energy generation in the U.S., electricity generation, is renewables.
Right.
So for steel industry, for the steel industry, and especially EAF producers, whose main focus on decarbonization is decarbonizing their electricity production, because that can allow them to get down to a very low number. They can still make the deals they need to make with producers to combine the renewable energy with their EAF production. And then I would note that the Trump administration, while yes, they've been fairly negative about wind, solar is the most rapidly growing form of renewable energy in the U.S., growing very rapidly in places like Texas. But also, the Trump administration has been more positive on nuclear. So I think there is still a hope, and it is something we think needs to be part of the mix to promote a resurgence in nuclear production in terms of another zero emissions baseload type of production, whether that's traditional nuclear or the new SMRs. I think that's part of it. The Trump administration's also, they've kept the carbon capture and storage tax credits, so there's still promotion for carbon capture. And they have, through the Department of Energy, financed some improvements, especially for integrated mills, in terms of efficiency improvements, electrification of some slab reheat furnaces and some other efforts. So they're still actually promoting in different aspects steel industry decarbonization outside of the renewable energy area. But I think overall the mix allows the U.S. industry, which has from the very beginning been driven by its own, by market forces and what it sees as its best pathway to increased competitiveness and competing with each other. I think the U.S. industry is going to continue on the same path.
Okay, thank you for that. I want to pick up on that, your comment about nuclear, particularly SMRs, which is now getting a lot of attention and discussions of, obviously data centers, but also the steel industry. So let me start with you, Jose. Are you seeing interest in Mexico, Argentina, Brazil in small modular nuclear?
Yes, matter of fact, we started a project based in Argentina, a small modular reactor. We already have the site all set because it was a former combined cycle that was phased out because of assurance issues, because it was out of guarantee. But the permitting issue scared out of the project. I mean, it's too long, and you need to face a social resistance that, knowing the community, we know that we're going to be struggling the process, and it's not going to be succeeded in the times that we expected. So unfortunately, we rejected the go-forward process.
That was in Argentina, you said. Okay, do you see
No,
any...
in Mexico, we are seeing most renewables.
Okay.
Maybe it's a mixture, half and half, of solar and batteries with wind farms. We have very good power operation factors in Mexico as well in Argentina. That's why we invested 60 megawatts capacity in wind in Argentina, and we expect to do almost double that size in Mexico in the near future.
Okay, thank you. I guess this can be for Dr. GHENDA. I mean, the nuclear for a period of time within Europe was sort of being phased out, but now it seems like there's renewed interest, again, given the persistently high cost of natural gas and other renewable electricity. Do you see nuclear, particularly SMRs, as sort of having impact on the steel industry or contributing to steel industry decarbonization over the next 10, 15 years?
So we need clean energy.
Yeah.
So as long as we cannot have all of it from renewable, we need to stay open also for nuclear.
Yeah.
because we don't want to use fossil. So we need to have this energy for somewhere. So as long as we don't have 100% renewables, it makes sense to also look into nuclear.
Yeah. Dr. DOHNOMAE? Sorry.
I'm sorry, I don't have any.
Okay, I apologize.
idea
Yeah, and
about
that's a
nuclear.
difficult. I want to ask Dr. Huang, though, because, again, just reading from the outside and looking at the development of China's technology, beyond solar panels, we're seeing hydrogen. We're seeing, or renewables, just tremendous investment in renewables year after year. But it also, if I read it correctly, China government is making significant investments in nuclear. And I think I read somewhere that, half or 2/3 of the nuclear plants that are being built around the world are being built now in China. So my question is, where does nuclear energy fit into steel industry decarbonization and maybe general decarbonization in China? Does that?
简单帮我翻译一下。
也投资的这个核能，然后核能的话，如何在就是我们这个钢铁当中的话，就是实现这个，就帮我们实现低碳。
I'm not reached this parallel this area. 我在这方面没有太多的研究。
He doesn't have like working experiences
Okay.
in this aspect, so
Okay,
he
all
doesn't
right.
have any comments.
Okay, thank you. Thank you for that. I'm getting a hint here that people in the audience might have some questions. So we can go back and forth. So please, if you'd like to raise your hand, ask questions. If it's directed at a certain panelist, please do so. Or if it's a question you'd like multiple panelists to address, please indicate that as well. Yes. Front row. The man.
My question is in fact to you.
Okay.
When you showed, the contribution of each
Yeah.
component on how
Yeah.
the emission was reduced over the years,
Yeah.
what I've noticed, the grid intensity has
Yeah.
such a small number.
Yeah.
What's the reason behind that?
It's a function of, again, there's a couple pieces. One is, I'll use the word forecast or assumption, right, about what the pace will be. And it also is tied to the, still the percentage of EAFs, right? So, again, it's country by country, region by region. So the size of the reduction in grid intensity in a given region, if you will, applied to a certain size of an EAF industry is kind of how you get to that. So, yeah, there certainly will be some countries which show a much steeper rate of grid de-intensification, but then, again, it has to be applied against the EAF. And obviously, we model electricity going into all the other operations in the furnace, but it's clearly in a plant, but clearly it's primarily for EAF. And again, all of these, this is changing daily, right? And so each country, each region's renewable energy path is sort of what the basis of this is. Come on, folks, please. Yeah.
Today, we don't have anybody on the panel from India. Could maybe the panelists speak about developments in India and where the steel makers are thinking of taking capacity there? Because that's one of the big growth areas.
Okay. I could take, if someone would like to start, or I could start, and you guys can react. Again, when people think about decarbonization of India, they're mainly focusing on the topic of growth in blast furnaces, right, as being the key contributor there. And the question of, the number of blast furnaces, the longevity of their life. But what's not equally understood is the so-called secondary sector, which is EAFs and IFs, electric furnaces and induction furnaces, which actually have a CO2 intensity much beyond what the blast furnace. You're talking about 3 kilograms plus of CO2 per ton of steel. And, the thinking was, or the thinking for some people outside of India, was that, well, they'll just go away, right? The integrated, the tier 1 guys are building so much capacity, they'll just push the other guys out. It's not happening, it's not going to happen, right? There's sort of social and political reasons that secondary sector is not only continuing, but is actually expected to increase. So personal opinion, we think the Japanese integrated industries are also at the forefront of technology innovation for blast furnace BOF, right? Tata Steel in Jamshedpur has got the blue blast furnace project going on. JSW's got a number of projects. So, you know, bottom line, I don't know if I'm giving you a good answer, but I think there are many pieces to the India steel puzzle. But again, our personal view is that I think we are going to see a lot more innovation, leading innovation coming from India, from the blast furnace sector, and reforming that secondary sector is, you know, it's not an easy technology solution to replacing coal-based DRI when the coal is all local. You know, the economics of that are extremely difficult. So, please. Okay. I'm sorry, let me just say, anyone else want to comment on India? I'm sorry, please, no? No. Please.
Yeah, this is okay.
Yeah.
So as because I'm from India, I think I'm the only one in the hall.
So please.
Representing Tata Steel. You're right. Basically, we are growing with blast furnaces, and we are trying technologies which can actually improve blast furnaces. So for example, in Tata Steel, we are trying two technologies. One is Haisarna. We are trying to put up a demonstration plant in Haisarna, which is, you know, which is claiming to be 20 to 50% lower CO2, because it eliminates many of the sinter making, pellet making, and coke making steps. Second that we are trying is easy melt process, which is more of a top gas recovery and electrification as much as possible. So basically, we are trying to improve the blast furnace processes. You discussed about the secondary steel makers. So what government is trying to do there, because they are going to stay, they are not going to go away. So what government is trying to do is they are trying to bring a green steel policy, because some of these secondary steel makers are also using a lot of scrap. So they are trying to incentivize by bringing certain policies like green steel policy, and also government is trying to put a carbon trading scheme in India. So with all this, there's some kind of fund that government is trying to bring. But yes, ISPs are the one who are majorly actually contributing in bringing innovating technologies in India, and blast furnace is the way at present. Tata Steel also made EA, but that's a small. Kind of pilot plant that we tried, and there are plans, but the major growth will remain blast furnace centric and efficient blast furnace production. So that would be.
I've got questions for you, but now we can pick it up later. Other questions from, please.
Sorry, me again.
Yeah, you again.
Caroline Ashley from Steelwatch. I'm interested, we heard various numbers for cuts in emissions, I think, from blast furnaces. And my question is, what exactly do people mean? If my blast furnace chimney is this, with the black top, but my blast furnace site has coking ovens and sintering and everything else, and then somewhere downstream, so I don't know whose hat this is, there's the methane coming out of the coal mine. When people say 40% emissions cut, like for the Course 50 in Japan, or 70%, Dr. Rizwan, for the slide you had on carbon capture on your slide, I think you had 60, 70. What's the denominator in this? Is it just this?
No.
Or is it this whole table? Are any of these numbers taking into account the methane? And are they taking into account the emissions from the other parts of the site?
Yeah, I think, sorry, I'll jump in again, but please. Most of the analyses I've seen, and I think the correct way to look at it, is you're looking at the entire primary end. So it's 40% not just on the blast furnace, but it's on the whole configuration. And actually, you know, there's a lot of optionality in the way steel company will kind of utilize off gases, right, from coke batteries, from power plants and all that. So certainly when we talk about up to 30, 40%, it's for the entire primary system. Now, you could even include hydrogen or electrification of rolling mills. But specifically to your question, it's not just the blast furnace, because the blast furnace taken by itself, you know, A isn't always the main contributor, and there's just a lot of optionality into how that gets done. All return back to you guys, almost at the end. Anything that we didn't cover that you'd like to make? Any other comments, other things that you would like to sort of say? Please.
I want to say, do you remember the third words I mentioned, the cooperation? As in your presentation, I heard a lot of times mentioned about China, about the CBAMs, the carbon emissions, the value, the default value for China and other countries. You are right. The China disagree and against the date of the 3.66 in China. Although the CBAM was generally designed to promote green production and reducing carbon emission, I think it's good. It's very silent. But this dates, value default dates, is not right and not fair for the China's industry iron steel sections. So we call for closer cooperation. The Chinese steel section stand really work together with an open and inclusive mandate to build a green innovation and win-win industry, supply and service chains across the steel sections. Thank you.
Okay, thank you. Anyone else? Parting thoughts? Yes, Dr. GHENDA, please.
Thank you. Thank you very much. I remember one of the reports of the World Steel talking about acceleration factors for decarbonization. One of those factors was cooperation. Cooperation is one of the accelerator factors. For sure, we need to cooperate, to work together. Then I will come back to the question, what is the CO2? What are the numbers we are talking about here? We're coming down to the methodology to calculate, to monitor, and down there to certify in order to make sure that when we talk about 1 ton CO2 in Europe, it's 1 ton of CO2 in China, it's 1 ton of CO2 in India and elsewhere in the world. So we need to make sure that we're talking the same language. Now, coming down to the values, default value in CBAM. The default values are there in order to make sure that those who import into the EU really declare their values, their data. So you have the chance to report your data according to the methodology that has been defined by the Commission for CBAM. And then they will have the chance to see your numbers and to calculate the values that are really fair for you.
So that's a great introduction, again, to some of the other panels that are coming up that are specifically addressing this question of how you measure, how you monitor, and how you... I'd like to thank our panelists, thank all of you for your attention. Thank you, Rizwan.